Hello.
Sir. Yes, sir, you're audible.
Okay, ठीक है. So we know how to calculate the thickness of heads. Now we also know that for spherical head, everybody please keep a calculator. For spherical head, okay, we know that head thickness is given by this equation: crown radius stress intensification factor divided by 2fj. Okay, and what is W? You also know that W is the stress intensification factor, and it is 1/4 3 plus root over of R3 by R1. Now R1 is the knuckle radius. Now it is given that J equal to 1. Okay, for odd roll number, you will take this value, and for all even roll number, you will take this value. Okay, even. And if crown radius is 1200 millimeter, knuckle radius is 72 millimeter, so you find the head thickness. Okay, do it. Whatever.
Hello, sir.
Ah,
Sir, the pressure value, the stress value, and pressure and stress
okay.
value is not given.
Yes. So the pressure you will take 0.3 Newton per millimeter square, and the allowable stress or permissible stress consider 130 Newton per millimeter square. Is it over? Is it okay? Hmm? What is the value?
Sir, 2.88, sir, for even number, sir.
And 2.45 mm for even odd number, sir, odd roll number.
Okay.
Sir, 2.45 for odd.
Sir, 2.88 mm for even.
Now, one thing, suppose we need to build a vessel of volume V. Now, suppose this volume is 100 meter cube. So, what should be the ratio of length to diameter? Suppose volume V is the fixed amount. Now, this may be like this, okay, or this may be like this also. So for both the cases, the L by D ratio is different. Now, how to calculate the optimum L by D ratio? So, this optimum L by D ratio can be estimated considering the cost of fabrication. It can be estimated by the material or construction needed. So our target will be the optimum L by ratio for the low cost. Our target may be based on L by ratio for the less material used. So we will see a technique where we will see how to estimate the optimum length to diameter ratio of a pressure vessel considering the cost of fabrication. Now, optimum proportion of cylindrical vessel by considering cost of fabrication. Okay, so for that we have some basic assumptions such as, let us assume cylindrical vessel closed at both ends. It is not, it is closed at both ends by if we consider the flat ends, then the calculation will be very easy. Rather, we are making some complicity in here by considering the elliptical head. Okay, the front head. If we consider flat head, then it is very easy calculation. So, by considering both heads by elliptical, by elliptical heads whose major to minor axis ratio is 2:1. Now this is our assumption. And for the symbol, the diameter of the vessel, dia vessel equal to D, considering length of cylindrical cell L. So we can write, then what is the volume of cylindrical cell? Volume of cylindrical cell. What is the volume of cylindrical cell? It is nothing but pi by 4 d square into L. No confusion. Okay, pi r square L or pi by 4 d square into L. And if we consider, so this is our okay. This is our volume of the cylindrical cell, but there is elliptical portion having 2:1 major to minor axis. Now again, volume of elliptical head. Now what is the volume of elliptical head? So this is the volume. Am I correct? So it is given as, if you see the calculate, it will be pi by 24 into d cube. Okay. pi by 0.24 into d cube to the power d cube. So now these two volume must be equal to our total volume of the vessel. So the condition is that the total volume capital V is a constant amount and it is equal to 2 into then what is the value of L? You do it. You find the expression for the L. What is the value of L? Do it quickly. Do it quickly. Bolo, tell me. What is L?
Sir, 12V minus pi d cube upon 3.
Okay, fine, I understand. So it is nothing but 4b by pi d square minus d by 3, is it?
Yes, sir.
Yes,
Yes, sir.
Our question is to find L by D ratio. So we can also write L by D. If we take D common in the denominator, then it will be 4b by pi d cube minus 1 upon 3. Okay, so it will be like that. Now, now we assume, since we are finding the L by D ratio based on the cost of fabrication, so suppose CS is the cost of cell per square length, means per square meter, okay, cell material. And suppose CA head costing should more than the cell construction cost. So cost of the head per square length, and we are considering here that is the 1.5 times of the cell fabrication cost, assuming it may be any value, 1.5, any value, it is arbitrary value, okay. We are just considering it may be 2 times, 4 times, any fraction of times, whatever, but more than the cost of the cell construction. And we also know in the last day we saw a video, suppose that is the cylindrical disc having diameter d, and when we are making a cell, sorry, we are making a disc heads, elliptical or spherical, whatever the formed head. So that is the d prime, and we know that the d greater than the d prime, because to forming the heads there is a missing in the diameter. So it is very general. So here we also assuming the diameter of the circular plate for forming an elliptical head for forming an elliptical head, can be considered as 22% more than that than the internal diameter of the cell. Okay, so that's we are considering 22% more. It may be more than or less than 22%. So here with the value is also arbitrary. Now, so you get the expression, what happens? Now, you get the expression for the total cost. Total cost of vessel fabrication. Okay. You find it. PPTCT total cost. Then this is the cost for the cell site multiplied by the cell site material area. So that is nothing but the pi d into L, pi dl, plus head. Head construction cost is CH, but we can write it as CS into 1.22. Sorry, 1.5. It is not 2 to 1.5. So that is CS into 1.5. Two heads are there, and the flat plate area is nothing but the 1.22 into d square. So is it correct or wrong? You tell me. Is it correct or wrong? Is it fine? Fine. Hmm? Hello, Chimankar. Chimankar is there? Is Chimankar there? Let me see. You find it whether it is correct or not.
Hello, sir.
Bolo.
Yes, sir, it is correct. 22% greater. So it is right.
Okay. Then it is correct. Let me see. Where is Mr. Chivankar? Anyway, I'm not finding him. Then the rest portion is very easy, as you have find the maximum and minimum in your calculus. So you see L is a variable, D is also variable, so both variable. So we will substitute the L value here. So substituting L, we know the value of L. So the CT begins CS into pi D into L is nothing but we know 4b by pi D square minus D minus 3 and 1.5 into 2 equal to 3 CS here and 1.22 D square. Okay, now you find the simple value CT. So what is the value of the CT? You do it simplification. So it will be 4 CS to do the simplification. So CS into pi D into 4b by pi D square minus CS into pi D square by 3 plus multiply 1.22 square. What is that value? 1.22 square into 3. What is the value? 1.22 square into 3. What is the value?
4.46.
4.4652.
Okay. 4.465 into CS pi D square by 4. Okay. So that is equal to, so on simplification, what is the value? Here the D will goes up, pi will be vanished. So that is the 4 CS V by D. Okay. And so you find the expression of these two terms. Okay, this minus this. What is the value? What is the constant? Pi, if you multiply by pi values, so it will be CS into D square. So what is the constant term? If you take the CS D square as common, so what is the value of the constant term? It should be a positive term. And what is the positive term?